Hi everyone, in this video we are going to prepare our SimuLink model for a code generation so that it can be integrated into the ArduCopter. On the right we have a stripped down version of the ArduCopter main attitude controller, which consists of one P controller and one PID controller for each roll, pitch and yaw axis. The gain value of these controllers are extracted from the parameter file and they are in here. So let's load them. So in order to generate source code, we first need to change a few steps. And these are, firstly, we need to change our solver type to the fixed step. And also change sampling frequency of the solver to 1 over 400, which is also the sampling frequency of the ArduCopter controller. And then we will go into the hardware implementation and change the target hardware to ARM compatible and ARM Cortex-M, which is F4, F7 and H7 microcontroller uses. And then we will go into the code generation and change our system target file. The system target file will be embedded coder, and our target language also be C++. Since we don't want to build the code we generated, we click generate code only and then package code and artifact, which will be easier for us to just copy and paste to the ArduCopter. And then we will go into the optimization and change the default parameter behavior to tunable, which will allow us to access these parameters inside the source code, inside the generated source code. And then we will leave everything as it is. Click OK. And inside our model, we also need to change a few things. Let's start with the PID controller block. The PID controller block needs to be in discrete time, otherwise the SimuLink will not be happy. And then we also need to change our input and output precision type, data type, and these need to be single precision since ArduPilot on the hardware use single precision for its calculation. I already done that before, so let's just check and make sure. There it is. So if we go into the apps and embedded coder, and also if we click here and click code mappings, the following screen will show up. And as you can see, it gives us details about input, output ports, our model parameter, which are our gain in this case, and block parameter and their data visibility. So since we want to access our input and output port, we want to change these to public. We also want to change model parameters to public as well, because we want it to be accessible. And on the function side, we double click on the step and click configure arguments for the step function prototype. We see that our input and our output displayed here. We can change their name as we wish, but we are not interested in that for now. So since we input vector value, we have to assign this to pointer. And also we can change this to reference or pointer, it doesn't matter. So it warns us that there is a problem. If we go in here The input and output port must be configured as public and their member access method configured as none. So if we come here, we also need to change their member access method. Let's try again. Okay. If we click OK, and we can generate code now. The generated codes, all of the generated codes are actually inside this folder, and there are a lot of files that we are not interested in here. So that's why we choose the package everything option in the configuration. And if we look at the zip inside the zip file, sorry. So if we look at inside the zip file, we see that we have far fewer files in here compared to the generated one. These are lots of met file that we are not interested. Let's close this one, and so if you look at our source code, generated source code, it consists of one step function, one initialize function, and one terminate function. Inside the initialize function, it actually initializes the integrator and derivative value to 0. And step function is the one we are going to interacting with constantly. So these are the files that we will be using inside the ArduCopter. But the top one, the main file, is actually generated just to be used as an example, how we can interact with our model. So inside our ArduCopter file, we will also call our model like this. And if you look at the header file, we see that our game value are displayed here as well, with the same name we use inside the MATLAB script. And their initial values are assigned in here. Thank you.